This is Mr. Beck Does Your Homework. This is AP Physics, Homework 9.4, questions 11, 12, and 13. A pair of oppositely charged parallel plates are separated by 5.38 millimeters. So I've got my plates, and the distance between them is 5.38 millimeters. A potential difference of 628 volts exists between the plates. So I know that my voltage, my potential difference, is 628.0 volts. What is the magnitude of the electric field strength in the region that is located between the plates? So I want to know about the E field here between the plates. Well, this is my distance and this is my voltage. I know that my E field is given not only in newtons per coulomb, but in volts per meter. So it's the voltage divided by the distance. I know my voltage, I know my distance. I have to be sure to put that in meters. So I could write this as 5.38 times 10 to the minus 3 meters. That's what milli means, 10 to the minus 3. So that's going to be my distance. So if I do E is V over D, I will get myself my electric field strength. How many volts per meter? Volts per meter. What is the magnitude of the force on an electron that is in the region between the plates at a point that is exactly 2.6 millimeters from the positive plate? This you actually don't need here, because since the electric field from positive to negative is continuous and constant and the same all the way throughout, it doesn't matter where that electron is, it's going to feel the same force. So I know that the charge on the electron is 1.6 times 10 to the minus 19th, the magnitude. I know it's negative. But that's the magnitude of the charge. If it's asking for the force, I know that F equals Q times E. The charge on the electron times the electric field strength. So you know Q, you know E, you can get the force. Now the electron is moved to the negative plate from an initial position 2.6 millimeters from the positive plate. What is the change in the electric potential energy due to the movement of this electron? What we know here is that the work done is going to be the change in the electric potential energy is going to be the amount of force times the distance the electron travels. So also in electric field language, this is going to be QED, because force times distance, that's QE, that's D. So we could write it as QED to get my change in electric potential energy. So the only tricky part here is figuring out the distance. Well, the total distance is 5.38 millimeters. This is from 2.6 millimeters from the positive plate all the way down to the negative plate. So my distance for me is going to be 5.38 millimeters minus the 2.6 millimeters. And that will give me my number of millimeters. So you could write that as times 10 to the minus 3 meters. And now you've got your distance to plug into QED or to plug into force times distance. So you can take this answer, multiply it by the distance, and get your work done or change in energy.